How airplanes overcome gravity. Airplanes defy gravity through the principles of aerodynamics, particularly through the use of lift. The wings of an airplane are designed to create a difference in air pressure between the top and bottom surfaces, resulting in an upward force called lift. This lift counteracts the force of gravity, allowing the airplane to become airborne. The role of lift in flight. Lift is generated by the flow of air over and under the airplane's wings. The wings are shaped with a special curve, called an airfoil, which causes air to move faster over the top than the bottom. According to Bernoulli's principle, the faster moving air over the top creates lower pressure, while higher pressure builds below, lifting the airplane into the sky. Thrust and its contribution to flight. In addition to lift, thrust plays a crucial role in keeping an airplane airborne. Thrust is generated by the airplane's engines, which push the aircraft forward. As the airplane moves through the air, its wings generate more lift. Without sufficient thrust, the airplane cannot maintain the speed needed to keep generating lift. The importance of airspeed for lift. For an airplane to achieve and maintain lift, it must reach a certain airspeed. This is the speed at which the airflow over the wings is strong enough to create the necessary difference in air pressure. As the plane accelerates on the runway, the speed increases, allowing lift to overcome gravity and the airplane to take off. The balance between lift and weight. For an airplane to stay in the air, the upward force of lift must balance the downward force of weight, gravity. If the lift exceeds weight, the airplane will climb. If the weight exceeds lift, the airplane will descend. Pilots carefully control the airplane's speed, angle, and altitude to maintain this balance during flight. How airplane engines contribute to lift. Airplane engines provide the necessary thrust to propel the aircraft forward, but they also help sustain the airflow needed to keep the wings generating lift. By maintaining a high enough airspeed, the engines ensure that the wings continue to receive the necessary airflow for lift generation, even at cruising altitudes. Control surfaces and flight maneuvers. Airplanes are equipped with control surfaces like ailerons, rudders, and elevators, which help pilots manage the aircraft's orientation and stability. These surfaces allow the airplane to turn, climb, or descend. They adjust the airflow around the wings, changing the distribution of lift and helping the pilot control the plane's trajectory and altitude. Gravity and the Earth's atmosphere. Gravity pulls everything towards the Earth, including airplanes. However, because the air around the airplane is in constant motion, the shape of the airplane's wings helps manage these forces. The upward lift generated by the wings is greater than the downward pull of gravity during flight, which keeps the airplane aloft. The role of angle of attack in flight. The angle of attack refers to the angle at which the airplane's wings meet the oncoming air. By adjusting this angle, pilots can increase or decrease lift. A higher angle of attack can generate more lift, but if the angle becomes too steep, it can cause the airplane to stall, where the lift is no longer sufficient to overcome gravity. Continuous motion and lift generation. Airplanes must maintain constant motion to continue defying gravity. This is why they cannot simply hover without thrust. As long as the engines provide thrust and the wings generate lift, the airplane will continue to stay aloft. This continuous motion ensures the necessary forces remain in balance, allowing the airplane to fly.